all your coworkers are probabilistic. When people complain about LLMs, we forget that we as humans are even more hard to deal with. Have you ever received a feature request, discussed it and felt totally aligned, and then you go and see that the result, only to think, this is not what I meant at all. For decades, our careers were built on deterministic compilers. Now we have machines that behave like people, creative, context-hungry, and occasionally confidently wrong. If you don't shift your mental model, you will see AI as a useless toy and miss its real power. In this video, we are gonna cover first why the unreliable coworker feeling you get from AI is actually a mental model problem. Second, how curating context is the key to making an LLM effective and why it is a gift to your human engineers. Third, the three critical differences between an LLM and a human that you absolutely cannot ignore. And fourth, the boring but proven engineering practices that turn AI from a frustrating mess into a powerful collaborator. And by the end of this video, you will have a mental model for working with AI assistants, turning frustration into effective collaboration. So let's dive in. If you have been working in software for long enough, I'm sure you have had this feeling like, this is not what I wanted kind of feeling, right? A coworker thought you were aligned, but the idea got lost in translation. With humans, we are perfectly fine, we accept this, we iterate, we clarify the specification, and then we fix it. But now, we have that exact same dynamic with large language models, or LLMs. But somehow, we see it as a critical failure of the technology because when it comes to machines, in general, we simply have higher expectations. You know what I mean. Sometimes LLMs produce code that it is technically related to the prompt, but not exactly what you meant. That feels familiar, doesn't it? Here's the thing. The discomfort you feel is not a flaw in AI. It is the friction from an outdated mental model grinding against a new reality. So, if the LLM is like a new teammate, how do we manage it? As I always say, everything starts with context. And this is where the stakes get higher, because current LLMs have actually limited agency capabilities. A new human teammate, if they are struggling, they can look for information, they can search a wiki, browse the codebase, or ask someone, another human, for help. But an LLM, on the other hand, it cannot do it. It has a hard context window and limited ability to pick outside of it. If you don't show it a particular internal module, then as far as the AI is concerned, that module doesn't exist. Early on, I get frustrated when I ask an agent to apply a pattern, and it would change one file but ignore three other files or in two other places where the same pattern existed. Why? Well, because those files weren't in its view. It didn't know they existed. Things got better when I stopped expecting the model to find what matters and started curating what matters. I wrote down project-wide rules in simple markdown files. I created high-density overview documents. I pointed the model at relevant files explicitly instead of hoping it would guess. And here's the powerful side effect I mentioned earlier. A system that is well documented enough for an LLM to navigate is a system that is a dream for a human engineer to join. Think about the worst code base you ever onboarded to. I bet the information was spread across people's brain and a decade of GitHub history. You have to rely on tribal knowledge. LLMs cannot survive on tribal knowledge. They force you to make implicit knowledge explicit. They just make the pain of poor documentation unbearable and faster. Well, the coworker analogy is powerful, but it is a trap if taken too literally. Most people get this backwards. An LLM is not a person, and treating it like one leads to disaster. There are three critical differences. So first, memory. When I explain a design principle to a colleague of mine, I expect them to remember it, but with an LLM, every session starts as if you are never met. This means you cannot teach the model. You have to teach the environment around it, encoded in instruction files and reusable prompts, in automatic checks that reject the rule violation changes. Second is judgment. By default, LLMs are designed to agree with everything you say, everything you ask it. They will cheer for your ideas and happily build any silly thing you ask for. The best engineers I know will look at the requirements and say, this doesn't make sense. An LLM is not gonna do that unless you explicitly tell it to do it. So one of my standard instructions is now, okay, criticize my design, lay out alternatives, advise me on a better approach. You have to ask for the punch back because they are not going to volunteer for it. Third, and most important, responsibility. Models have no skin in the game. They don't have motive, egos, or even ambitions for now. And they have no responsibility either. The AI did it is a tempting phrase to throw in a meeting, but it is meaningless for your manager. It is meaningless for you as well, because the model doesn't decide to deploy untested code. The human who wired the system together did. And if something goes wrong, the fault always lies with the operator, not the tool. So if you accept that all your coworkers, carbon-based and silicon-based, are probabilistic, what do? The reassuring answer is that you don't need a revolutionary new discipline. You just need to apply the old boring practices with more rigor. Pause for a second and think about the last time an LLM frustrated you. Did it involve a long vague prompt, a long wait, and then a big disappointing blob of code? I'm sure it did. That is the equivalent of throwing a vague goal at a coworker and just hoping for the best. But there is a better way. First, be clear about the work, the goal. For example, asking to build me a blog is not a requirement. It is a kind of wishful thinking. Write down what you actually care about. For example, instead of build me a blog, try write a single Python function that takes a markdown file as input and returns HTML using only standard libraries. You see? You can define what you don't care about and which corners you are fine cutting with a very specific guidance to the LLM. And this specificity is crucial. Second, you can shorten your feedback loop. Ask for a plan. Poke holes in the plan. Let the model implement one small piece, run the checks, see what happens, repeat. Don't let it disappear for 2 hours. Keep the steps small and visible. And third, externalize knowledge. If the way something works only lives in someone's head, it is invisible to the machine. Writing down the system design and constraint helps everyone, including your future self, to understand the system at hand. And finally, embrace automated skepticism. Tests, linters, CI, branch protections, all the things that make it harder for a rushed human to ship garbage are exactly what makes LLMs sane to work with. Think about it, if you have a solid test framework in place with the proper harness and automation, AI agents become incredibly useful. If you don't, plugging them in is just an amplifier of the mess you already have. None of this is new. We have been using these tools for decades to code with human beings, I know. But today, the noise source just got faster and cheaper. That makes the old answers more urgent, not less relevant. So, what is the big takeaway? Well, that feeling or frustration with AI doesn't come from the tool itself. It comes from a mismatch in expectations. You have been treating a probabilistic teammate like a deterministic compiler. The solution is to stop fighting the tool and start managing the system. It is about applying the rigorous engineering practices we should have been using all along. Clear specs, short feedback loops, externalized knowledge, and automated checks. Here is a concrete next step you can take in the next days. If you want to train this, you can pick one small annoying coding task, but instead of just prompting for the code, first write one paragraph specification for it, then ask the AI to create a step-by-step plan based on that spec, and only then ask it to write the code for the next one. And notice how the interaction changes. So in short, stop fighting the tool and start engineering the system. And that's all for me. Thank you for watching and see you in the next one. Bye.